Good evening, class. This will be the last video that you will be receiving from me. With this last video, we are going to discuss section 1.4, and I am going to actually work through all of the examples found from the slides. We will be covering objective number 1 and objective number 3. So let's begin. So objective number 1, solving problems about different denominations of money. I encourage you to pause the video now, review the notes that you can see on slide 9. You can come back to the video. We're going to try all the problems. If you want to try the problems on your own, that's great. Check your work, watch me do the work. Or if you simply want to just watch me go through the problem, that's fine too. So let's begin. So again, we're on section 1.4, objective number 1. So our first question can be found on page 92, question number 1. It says, what amount of money is found in a piggy bank containing 38 nickels and 26 dimes? So with number 1, we have 38 nickels, 26 dimes. We want to find out how much money that is actually representing. So we take our number of coins and we multiply them by the dollar amount. A nickel is 5 cents, a dime is 10 cents. So 38 times 0.05 and 26 times 0.10. We type that into our calculator. 38 times 0.05, we get 1.9, which is $1.90 in terms of money. 26 times 0.10 is 2.6 or 260 in terms of money. We are adding those two values together and we get our answer as $4.50. And you can see that underneath question number 1 for the answer. Now, question number 5, if you see the notation on the lecture slide, it says make a table to solve. And if you look on page 92 with the question, you see that there is a table there that is partially filled in. We are going to continue to fill in the table, and we are going to use a table to answer the question. So number 5. Otis Taylor has a box of coins that he uses when playing poker with his friends. The box currently contains 44 coins consisting of pennies, dimes, and quarters. The number of pennies is equal to a number of dimes, and the total value is $4.37. How many of each denomination of coin does he have in the box? So let's fill in with what is actually given to us already. So we have pennies, dimes, quarters, and then this is our total value. So the top says number of coins, so I'm going to abbreviate that. Denomination in dollars means dollar amount, what each represents in terms of money. And then we have value in dollars, what it all multiplies up to being. So pennies and number of dimes is represented X. It's given that a penny is worth 0.1, that a quarter is 0.25, and that the value for the pennies is 0.01X. And they find that by multiplying straight across. So we know the dollar amount of a dime, that's 0.10, just like we had with number 1. So I multiply across 0.10x. So now I have to go and figure out what I'm going to write down as my variable for quarters to then find the value and so on. In the question it says that we have 44 coins. That is found by adding up number of pennies, number of dimes, and number of quarters. So let's figure out, using this equation, what our quarters is going to represent. Pennies and dimes are both X. We don't know what quarters is going to be. X plus X is 2X. So I'm going to subtract 2X on both sides. So 44 minus 2X is what the variable representation will be for our quarters. So we can put that right over here into the table. 44 minus 2x, multiply across 0.25 times 44 minus 2x. And the table is given that the total dollar amount is $4.37. Okay, we're doing good so far. So here we have our table. We have everything filled in. And that's the first part of the answer underneath question number 5 on slide 10. Now let's actually solve for the number of coins. So I take the first 3 rows and I add them up to equal $4.37. So 0.01x plus 0.10x plus 0.25 times 44 minus 2x all equals $4.37. Distribute. 0.25 times 44, I typed that in my calculator, it's 11. 0.25 times negative 2x is negative 0.5x. We write everything else. Combine like terms, 0.01 plus 0.10 minus 0.5 is negative 0.39x plus 11 equals 437 minus 11 negative 0.39x equals negative 6.63. Divide both sides by negative 0.39, and we get our answer as x equals 17. Now the x represents, again, pennies and dimes. So that means I have 17 pennies and 17 dimes. To find the number of quarters, I have to plug it into the 44 minus 2x equation. 44 minus 2 times 17, I am left with 10. So I have my answer. 17 pennies, 17 dimes, and 10 quarters. Let's continue on. Pause right now if you'd like to try the question on your own, or just continue on with me. Okay. Number 8. Notice again on the slide that it says make a table to solve next to question number 8. That's the best way to do this problem. Number 8, the bottom of page 92. Luke Corey works at an ice cream shop. At the end of his shift, he counted the bills in his cash drawer and found 119 bills with a total value of $347. If all the bills are $5 bills and $1 bills, how many of each denomination were in his cash drawer? So just like with number 5, I'm going to make a table. Probably made that a little too small. That's okay. I have heading, dollar bills, $5 bills, and total. So number dollar bills, dollar amount, and value. I'm going to try to squeeze this as much as we can. We don't need this. We know we have $1 bill and $5 bills, and total adds up to $347. So with number 5, we were given the variable for pennies and we were given the variable for dimes. Here we don't have that. We have to figure that out on our own. So I am just going to say arbitrarily, let's label the dollar bills as X. We are given that we have 119 total bills. We're going to use that information along with the X I just identified as being the $1 bills to find the variable representation of $5 bills. So the dollar bills plus the $5 bills have to add up to 119. So if the dollar bills is represented as X, that means that the $5 bills would be 119 minus X. And if you were to add these together, you'll get 119. I multiply across. 1 times X is just 1X, or simply X. And here the value for the $5 bills is 5 times 119 minus X. And just like with number 5, I'm going to add the first 2 columns to get the total. So X plus 5 times 119 minus X equals 347. Distribute. 5 times 119, type it in my calculator, I get 595. 5 times negative X is negative 5X. Combine like terms. Subtract 595 on both sides. Negative 4x equals negative 248. Divide by negative 4 on both sides. I get x equals 62. So the 62 here is the dollar bills. To find the $5 bills, I take the 62, I plug it back into this variable expression, 119 minus x. So 119 minus 62 gives me 57. So I have 62 $1 bills and 57 $5 bills. And you can see that answer on slide 10 underneath question number 8. Okay, our last example for objective number 1 is question number 11. Take the time to pause the video, try the question on your own, or follow along right now. So number 11 is on the top of page 93. In 2012, general admission to the Art Institute of Chicago cost $18 for adults and $12 for children and seniors. If $22,752 was collected from the sale of 1,460 general admission tickets, how many adult tickets were sold? So here I'm only solving for adult tickets, so I don't have to solve for both like we did with question number 8 and question number 5. So I'm going to create a table. I have our heading, adult tickets. Here we have children and seniors, and down here we have our total. So number of tickets, dollar amount, and value. So since we're solving for adult tickets only with this question, I'm going to label the adult tickets as X. It's given that the adult tickets cost 18, the children and seniors cost 15. So I multiply across. 18 times X. Now to find children and senior tickets, I'm going to do the same thing I did with number 8. I'm given a total of 1,460 total tickets sold. So that means that the children and senior tickets, if adult is X, are going to be 1,460 minus X. So multiply across. 15 times 1,460 minus X. And the total amount of revenue that was that came in was 22,752. So I add these two columns together to solve for X. 18X plus 15 times 1,460 minus X equals 22,752. Excuse me, distribute. 18X plus 15 times 1,460. Oh. I'm sorry, I just realized I did that wrong. This is supposed to be $12, not $15 for the children and seniors. So let's change that to $12. I apologize. 12 times 1,460 is 17,520 minus 12x equals 22,752. So again, make sure that you change this value right here from a 15 to a 12. I read the question incorrectly. Combined like terms, I have 6x plus 17,520 equals 22,752 minus 17,520 on both sides. 6x equals, I do the subtraction in my calculator. I am left with 5232 divided by 6, and x equals $872 tickets. And the x is what was the adult tickets, and that's what we're solving for. There was 872 adult tickets sold. Done. And you can see that answer underneath question 11 for on slide 10. Okay, let's move on. So now we're going to move on to objective number 3. Objective number 3 is dealing with problems about angles, and within this section we're also going to be discussing consecutive integers. So now you can pause the video, review the slide information, the lecture notes about objective number 3, and then you can come back and we'll do the problems. Our first problem is found on page 94, question number 25. So the question says, find the measure of each angle in the triangle shown. So I'm given a triangle. And now, I know geometry is something that we're not discussing in this course, but the lecture notes did tell you all the information you need to know about angles. And when you're given a triangle, all three angles add up to 180 degrees. So these three angles, even though they're variable representations, I'm simply going to take those variable representations, add them together, set it equal to 180, and solve for x, and then solve for the angle. So I have one angle is 2x minus 120, another angle is x minus 30, and the last angle is 1/2 x plus 15. And that all equals 180. I have 2x plus 1/2 x is 3.5x, or 3.5x, means the same thing. Negative 120 minus 30 plus 15 is negative 135, equals 180. Okay, add 135 to both sides. So I'm going to change this to 3.5x equals 315. Divide by 3.5. You get x equals 90. Now that's not what the question's asking for. The question's not asking us to solve for x. The question's asking us to solve for the angle measurements. So I take the value of 90 and I plug it into each angle. 2x minus 120. 2 times 90 is 180 minus 120 is 60 degrees. X minus 30. 90 minus 30 is another 60 degrees. 1/2 x plus 15. 1/2 of 90 is 45 plus 15. Another 60 degrees. So each of the three angles in this first question, in this triangle, equals 60 degrees. And you can see that at your answer on slide 11. Okay, our next question, 29, is dealing with vertical angles. Vertical angles are always congruent. They're across from each other. So you have the two variable representations. Take them, set them equal to each other. 8x plus 2 and 7x plus 17. So I take those two, I set them equal to one another. Let's solve for x. So subtract 7x on both sides. Subtract 12 on both sides. Subtract, 2. I get x equals 15. Again, we're not looking for x, we're looking for the angle measurements. So 8 times 15 plus 2, that gives me 122 degrees. 7 times 15 plus 17, another 122 degrees. So each of the degree measurements here is 122 degrees, which is what should happen because they're vertical. They're supposed to be congruent. Okay, last one for this objective with angles is number 31. 31 is on the bottom of page 94, it's talking about complementary angles. Complementary angles are two angles that add up to 90 degrees. So I'm going to take the two angle measurements that are there, 5x minus 1 plus 2x, and I'm going to set it equal to 90. Combine like terms, 5x and 2x, 7x minus 1 equals 90. Add the 1 to both sides. 7x equals 91. Divide by 7. I get x equals 13. Again, not solving for x, we're solving for the angle measurements. So you plug them into here. 5 times 13 minus 1 gives me 64 degrees. 2 times 13 is 26 degrees. And there we have our two angles. Okay, the bottom of slide 11 starts talking about consecutive integers. This is not a particular objective, it's just kind of thrown in there on the top of page 95 of the text. So please make sure you do review that information as well as the information on slide 11 and slide 12 of the lecture notes. And let's now do the last two examples for this particular section. Okay, so we're looking at page 95, question number 33. Now, consecutive means next to each other on the number line. So, with any type of consecutive questions, consecutive integer questions, you want to always determine your variables for the numbers first, and then use that information to plug into whatever the question's asking for. So number 33 says, find 3 consecutive integers such that the sum of the first and twice the second is 22 more than twice the third. Before I can do anything, I have to find my variables for the numbers. So I am given that I have 3 variables, 3 consecutive. They always are set up the same way. My first is always going to be x. Now I have my second, so I'm taking that and I'm adding 1. Now to then find the third, I have to then add 1 to the second. So x plus 1 will just be x plus 2. And always set up the same way. If the question said consecutive even or consecutive odd, that's when you then do x plus 2, x plus 2 plus 2 would be x plus 4. But here we just have regular consecutive. Now let's go to the question. The sum of the first and twice the second means equals 22 more than is add twice the third. So there we have now our equation. Now let's solve for x to then solve for the 3 integers. Distribute, distribute. X plus 2x plus 2 equals 22 plus 2x plus 4. Combine like terms on both sides. Solve for x. Subtract 2x first. I get x plus 2 equals 26. Subtract 2 on both sides. I get x equals 24. Great, that's the first integer. Now let's find the other two. So x is 24, x plus 1 is 25, and x plus 2 is 26. So I found my 3 consecutive integers according to the equation. And you can plug it into both sides and it will satisfy. That means they'll be equal to one another, so that means they're true statements. Okay, our last example is number 35. If I add my current age to the age I will be next year on this date, the sum is 95 years. How old will I be 10 years from today? So it doesn't say anything about being consecutive integers, other than the fact that you have to understand that if your current age is x, next year, which is only one more year, will be x plus 1. So again, current will be your first integer, next year here is your second integer. The question says if I take the sum of the 2 years, it's 95. Combine like terms. Minus 1, I get 2x equals 94. Divide by 2, x equals 47. So the x here represents the current age. The next year age would be that plus 1, but we're not looking for next year's age or this year's age. What are we looking for? We're looking for how old will this person be 10 years from today. So x represents today. So x plus 10 will be 10 years from now. So 47 plus 10, 57 years old would be how old this person would be 10 years from now. Right, that brings us to the end of section 1.4. Again, this video covered all of the examples that is listed in the lecture notes. Please take the time to review all the questions. I know this was a longer video. Go back, watch it again if you have to. Review the notes, review the pages in the textbook. Do the My Math Lab homework. You will be fine. If there are any questions, email me immediately. You know my email address. It's on the syllabus. But I do encourage that you are reviewing this video and looking at the lecture notes and the questions as you do the video. Pause it. Go back and look at it a second time. Again, any questions, email me, and I will see you guys again Monday evening to pick up where this leaves off. Have a good weekend.